Let's pick up where we left off here in section 2.6. We looked at how to add, subtract, multiply, divide functions. We looked at the restriction when you set up a division, because you can't have division by zero. And then we looked a little bit at the domain. Now let's look at the last operation, which is a composite function. And for a composite function, the symbol we use is this little zero. As I was saying before my video had some technical difficulties, the composite function, when you're working with it, or when you're asked to work with a composite function, you're going to see this little symbol right there, and it looks just like a little circle. Okay, that is our notation for composite function. Now, when I see that notation, then this is what I'm going to write. Notice what I have, f parenthesis g parenthesis x. What we're going to be doing is we're going to be taking the g function and putting him inside the f function. So we're going to put g of x into f of x for every x. It may be the situation where you have a g circle f of x. So the notation would be g parenthesis f parenthesis x, which means I would put f of x into the g of x function for every x. So I've written that down right here. F circle g means we're going to plug the g function into the f function for every x. G circle f means we're going to plug the f function into the g function for every x. So here we're putting the g inside f of x. Here we're putting the f of x inside the g. Let's practice that. So I've got two functions. F of x is equal to 3x minus 4. G of x is equal to x squared minus 2x. And I want to form the composition f circle g of x. So that means it's f of g of x. So I'm going to put the g of x function inside the f function. So I'm just going to pick this g of x function up and put him inside the f everywhere I have an x. What that's going to look like is a 3 times x squared minus 2x minus the 4. So all I did was put x squared minus 2x in place for x in the f of x function. Now we need to clean this up. So we'll distribute the 3 and then subtract the 4 from that. So we get 3x squared minus 6x minus 4, and actually that's our answer. There are no terms we can combine, so there is our answer. Not too bad. If I see the notation g circle f of x, that means g is outside and f is on the inside. So what we'll do now is we'll pick up the f of x function and put him in the g function everywhere I have an x. And notice I got x's in 2 spots, so I have to make replacements in both of those positions. So we're going to put the 3x minus 4 in place for x, and in the first x we have to square it. And when I put it in place for the second x, we'll have to multiply it by 2. When you're squaring a binomial, you must write it twice. Oops, I need a little more room there. I'll just write it over here. You must write that twice, 3x minus 4 times himself, 3x minus 4, and then use the FOIL method to multiply that out. Then we'll distribute the negative 2. Ooh, that's nasty. Let me fix that. Yeah, a little bit better. All right, so now let's work on cleaning this up. So let's FOIL out the 3x minus 4 times the 3x minus 4, and I'll get 9x squared minus 12x minus 12x plus 16. 3 times 3 is 9. 3 times -4, -12, positive 16. Okay. Then I'll need to distribute the -2 to the 3x minus 4, which would give me a -6x plus a 12. -6x plus not a 12, Melissa. What is that? -2 times a 3x is a -6x. -2 times a -4 is a positive 8. Watch your arithmetic. I make those mistakes as well. Now what we need to do is combine those terms. So I've got a 9x squared, a -12x, a -12x, and a -6x. So -12 and -12 is what? -24, and a -6 would be a -30x. And then a 16 and an 18, adding those would give me a positive 24. So that would be the result of G circle F, or G composed with F. We put the F function everywhere we had an X in the G function. Now, what if we were asked to find F circle F? That means it's parenthesis F parenthesis F parenthesis X. So basically what we're doing is putting the F function inside himself. So I am going to take the 3x plus 4, pick him up, and put him inside himself everywhere I have an X. So that would be a 3 times 3x minus 4, and then a minus 4. So I'll put F inside of himself. So we get 9x minus 12 minus 4. Oh my gosh. My brain and my hand are not working in unison right now. So 3 times 3x is a 9x. 3 times -4 is a -12. And then the -4 behind that. So when I combine my last two terms, I get 9x minus 16. Last operation is F circle G of 3. Be careful with these. It's always good to write what the notation means. This means F parenthesis G parenthesis 3. This means the inside part, G of 3, needs to be calculated first. So if I go to G and plug in a 3, I will get 3 squared minus 2 times 3. Okay, so let's clean that up. 3 squared is 9, minus 2 times 3, which is 6. So actually, G of 3 is a 3. Now that I've calculated the inside and found the value of G of 3, let's go to F and find F of that result, 3. So plugging a 3 into the F function, I will have 3 times 3 minus 4. So 9 minus 4 would give me 5. There would be my final answer. If at any time you have questions, please email me. But these aren't too bad once you get some practice and develop the hang of how to plug one function into the other. Okay, what if we're asked to go backwards, to decompose a function, which means you've got a function that's the result of a composition. Let's go backwards and find out who's the inside function and who's the outside function. So this is the way we're going to work it. We're going to always assume that f of x is the outside function and g of x is the inside function. And we want to break this down into what f of x is equal to and what g of x is equal to. So take a look at this function. I've got a function h of x, which is a composition, and it's equal to 2x plus 5, and all that is raised to the fourth power. And I want to figure out what looks like it could be an inside function, what looks like it's going to be the outside function. And then just break that down. The one that looks like it's on the inside, I'm going to call it g of x. What looks like it would be an inside portion to this function? I see 2x plus 5. That will be my inside function. That's the function that goes inside the f function. So what would f have to be? Well, it's the outside function. What's happening on the outside is something is being raised to the fourth power. So the outside function would be x to the fourth. So we just decomposed a function. We figured out what was inside, what was outside, and wrote those as two separate functions. And you can always check your work. To check your work, just take the g function and plug him into the f function and see if you get the original. Those are actually kind of fun. All right, let's look at the last thing. We've got an application here where we have two equations. Capital N of capital T represents the number of bacteria in a refrigerated food, where capital T is the temperature of the food and N is the number of bacteria. Okay, and also the temperature is in degrees Celsius. So capital N of capital T is 20t squared minus 80t plus 500. Okay, so this is the number, and this capital T is temperature. Now, when the food is removed from the refrigeration, the temperature of the food is given by this function. So remember, capital T represents temperature, but in this case, we have a little t, and it represents time. So you take that food out, you remove it from the refrigeration, and the temperature of that food is going to change over time. So we've got two equations, the number of bacteria for the temperature of the food, and then when the food is removed, we're going to look at the temperature of the food over time. Now, we want to find N circle T of little t. So we want to find a composition, capital N parenthesis capital T of little t. So we're going to take the second function, put it into the first function everywhere we have a t. So it's a composition. So let's work on that. The inside function is 4t plus 2, and let's put him in the n function. So I'll have a 20 times 4t plus 2, and that's going to be squared, minus 80 times 4t plus 2, then plus 500. That's what I get when I put temperature function, the second function, into the first function, capital N, everywhere I have a t. Now work on cleaning that up. So this is just working on part A. I'll pause it. Okay, so after multiplying and combining like terms, we end up with a composite function of 320t squared plus 420. Part B asks us to find the time when the bacteria count reaches 2,000. Remember, little t is time, capital N represents the bacteria count. So what I need to do is set an equation up of 320t squared plus 420 and set that equal to 2,000. Work on solving it. It's a square, it's a quadratic. It doesn't have the middle term, so I can use the square root method by first subtracting 420. And I'm going to need a little more room, so we're going to come over here. So if I take 420 from 2,000, I'm not trusting my math brain today. I get 1580. So 1580 is equal to 320 t squared. Let's divide both sides by 320. I get 4.9375. Let me check that. Okay, things were going well. Just had to check my work. So to solve this for t squared, I divide both sides by 320. And then to get to square, to get rid of the square and get time by itself, I need to square root both sides. And when I do, I'm square rooting the result of 1580 divided by 320, like that. And remember, when you square root both sides, you get a plus or minus. But since this t represents time, we got to throw out the negative. We only want the time to be positive. So when you take the square root of the 1580 divided by 320, you end up with time, that up a little bit, you end up with time equal to 2.2. But this is an application and we need to have a unit. And so time is in hours. So time is equal to 2.2 hours. I'll do HRS. So what does that mean? That means in 2.2 hours, the number of bacteria that's going to be on that food is 2,000. We wanted to find the time when the bacteria count reaches 2,000. So the bacteria count is equal to 2,000 when time is equal to 2.2 hours. Well, that's it for section 2.6. Let me know if you have any questions. And don't forget to work on that homework assignment in WebAssign.